Hi, and welcome back to New York Chem Coach. These are questions 19 through 25 from the New York State Chemistry Regents June 2005. Pause the video, answer the questions on your own, and in a moment I'll put the answers up, and then we'll discuss the explanations as to why the answers are the right answers. Okay, let's go through them. Question 19. Two types of organic reactions. Well, you have to use process of elimination here. An addition reaction, or choice 1, is an organic reaction. Sublimation is not. That's a phase change. Deposition in choice 2, phase change. Saponification is an organic reaction. A decomposition reaction in choice 3 is one of the four main types of reactions, but it is not an organic reaction. And evaporation, of course, again, is a phase change. So the only answer it could be is choice 4, esterification and polymerization. But again, look at the three wrong choices. You have a phase change, you have a phase change, and you have a phase change. So pretty much right away, you can eliminate those. They are not considered organic reactions. Let's look at question 20. Isomers of butane and methylpropane have. Well, you need to know what isomer means. We've come across the prefix isomer, or iso rather, before. That means something's the same and something that is different. In the case of an isomer, we have the same formula, but different properties because the structures are different. Butane, I have 4 carbons in a row, usually, and then I have all my hydrogens. So I have a long 4-carbon chain. For methylpropane, I would have 3 carbons, and then I'd have a methyl group here in the middle. So these are isomers of one another. Same number of hydrogens if I drew them all in, same number of carbons, different structure, so different properties. So isomer is a definition you need to know. For 21, we're looking at a redox reaction. Which particles are lost and gained in equal numbers? Well, that's electrons. Redox is short for reduction and oxidation. Remember, reduction is the gain of electrons and oxidation is the loss. 22, the oxidation state for a manganese atom. Any atom, could be manganese, could be any atom on that periodic table, has an oxidation number of 0. It hasn't lost or gained any electrons if it's in the atom state. 23, which compounds are classified as electrolytes? Well, for electrolytes, you really have 3 categories. You have salts, you have acids, and you have bases. So you're looking for those 3 categories, right? So a salt, you have a metal and a non-metal. An acid, where you have hydrogen in the formula, for example HCl, and then a base, where typically you have a metal and an OH. Well, again, process of elimination here. The answer is choice 1 because KNO3 is a salt. I have a metal, and then the polyatomic ion nitrate, which is nonmetals, and I have sulfuric acid. Remember, you have the acid table and you have a base table. It doesn't give you every acid or every base, but it gives you enough for you to most of the time be able to pick off of this the acids and the bases that are going to show up most on the test. If you look at the other choices, this is an alcohol. That's organic. That is not a base. For number 3, again, organic, and number 4, they're both organic. For 24, which compound is an Arrhenius base? Well, again, if you look at the bases, you'll see that calcium hydroxide is there. Arrhenius base just means that it provides OH in water when it's put in water. So any metal in OH is considered an Arrhenius base. For the other or alternative theory for acid bases, in addition to the metals in OH, ammonia or ammonium hydroxide would be the other base. And then finally in 25, according to one acid-base theory, water molecule acts as a base when it accepts. Again, for Arrhenius' theory, Arrhenius said an acid produces hydrogen ions in solution and a base hydroxide. Salts don't produce either. They produce ions, but no OH or H+. For this other acid-base theory, we have our proton donors and our proton acceptors. Our proton donors is considered an acid. That means it's giving up H+, but if it's giving it up, something has to accept it, and that's the base. The base is the proton acceptor. Thank you for watching New York Chem Coach. Check out more videos on NewYorkChemCoach.com and hit the like button below.